So thank you for introduction. So I don't need to introduce myself. The only thing, if you would like to connect with me, that's my Twitter ID, so Stepan Trofimo. And yeah, I'm working in the global black belt team, which covers OSS data in EMEA. And I'm focusing on Postgres and Oracle to Postgres migration, which is like really strong motion now. So I wonder how many of you do know Postgres, what Postgres is. I know that's like more like a SQL Server group, right? So I'm not sure how many of you like are aware about this great open source database. So for those of you that do not know what Postgres is, it's like really great open source database that is developed for over 20 years now. It's totally open source. It's free software that has long history of being really robust, really reliable, really extensive. By extensive, I mean there is a lot of, let's say, plugins to the Postgres that you can use if you need some kind of like special features, like for instance, geospatial features to be integrated in your database, or you need like some specific set of functions, for instance, today language processing, or you need special indexes, because there is also a lot of indexes that you can add to your Postgres core and like change your Postgres totally in like a geographic database, or just add some features to it. And what I wanted to talk about today, it's one of the extensions that is pretty specific, because it's not simply adding like a couple of functions to Postgres. It's just totally changing the Postgres to be scalable cluster. So instead of one instance, you would have like 20 or 100 nodes that are like together creating a huge database cluster that can handle even petabytes of data. And like going back to Postgres, it is totally fully ACID compliant. It's SQL standard compliant. Actually, no database is fully SQL standard compliant, but Postgres, like out of all of them, is the most SQL standard compliant. If you're thinking about like some advanced SQL features, you probably will find all of them in Postgres, like CTEs, so those with queries, window function. Foreign data wrappers are like the modern way of doing DB links. And actually, you probably never seen a database that has got like so many data types, because like out of the box in PostgreScore, you've got over 80 data types, and you can use like extension to even further extend those rich set of the data types. So in Oracle, for instance, you've got like just date. In Postgres, you've got time. You've got a date, which doesn't have like time component. You've got timestamp. You have interval even, which is also data type that you can use as a data type for your column in your table. And actually, I think that JSONP is something that made Postgres really famous a couple of years ago. JSONP, it's kind of binary representation of JSON that can turn your database in key value store. And other databases treat JSON like a normal data type, which is like text data type, and just like checking the syntax of it. Postgres does implement like the native JSON data type that is not a text, it's just JSON, which is in binary form, which means that it's really well compressed, so it's much smaller in size, and it got also like the special indexes to fetch some fields of the JSON. Okay, but enough about the Postgres itself. It's really important because like Citus, it's an extension to Postgres. So it's super important also to you to know like what the Postgres is. Of course, I will not cover all the richness of the Postgres in one simple slide, but I was just trying like to do the small introduction. And I will do the introduction about why I like Citus. At the beginning of my career, I was working in the Polish bank that is like, which was like a part of a big financial holding. And I was Postgres DB, and of course, like the whole bank was using Postgres as the core database system. And once we had this task to merge 4 banking systems into one banking system. And as you can, of course, suppose, it wasn't an easy task because already in one banking system, transactions table, which kept like all the transactions, was pretty much big. And we had a series of workshops. We've been like looking for a solution that can ensure us that this system, which gonna be over it was like 5 times even bigger, will be able to handle this increased data and load on the database. And actually that was like 7 years ago, I suppose. There's been no solution that could do the trick. So there's been a solution that was developed by Skype people. Actually, by one of the people that developed this solution was Dimitri Fontaine, which is now also working at Microsoft because of the Citus data acquisition. But this one required a lot of manual coding work to be done. So that was not an option. And actually, there's been no solution like that at that time. And why Microsoft likes Hyperscale Citus. Hyperscale, because that's the name that we use on Azure, because before it was just Citus, and when it became a Postgres PaaS service, it became Hyperscale Citus, so not like Citus anymore, but Hyperscale Citus. That's the full name, but a lot of people still refer to that as just Citus, right? It's just shorter. So inside in Microsoft, we do have this huge database that is gathering all the telemetry data from all the Windows devices all over the world. So it's really hundreds of millions of customers. And I know what you are thinking now. Yes, you can turn it off. You cannot send those telemetry data to Microsoft, to Redmond if you don't want to. Absolutely, you can turn it off on your machine. If you don't, you do send those telemetry data so Microsoft engineers can check out, for instance, how long it takes to generate some kind of graphical representation of a folder or something after you click it. So it's super important. And after each update, which you need to update your Windows systems, right? All those telemetry data are checked against the old data. If this particular feature haven't got slower, or maybe it's got much, much faster. And this is called RQV, which is analytics dashboard on top of this database. And taking the size of the Windows business at Microsoft, you might know that that's kind of critical system for engineers, from program managers, and a lot of people engaged in the Windows. So it needs to work really fast. It needs to be stable. It needs to serve those dashboards and data so fast as it can. And as you might suppose, it's really, really huge. But now it's it's about 2 petabytes in size. And that's actually my favorite story because Minwei, it's the principal engineer at Microsoft, which is working at this team. And he was experiencing this performance problems with the system. And one day he was just driving home and he was listening to the recorded conference talk in his car, and it was about Citus. So he got interested, and Citus was really small startup at this time. So he got interested and he thought, why not to do POC, right, with this strange new solution called Citus. They did POC and the results were really impressive. So Minwei and the team decided to go with Citus and migrate this over 1 petabyte of data, because that was the size at this time, to migrate it to Citus, and it's still working on Citus at that time. And a few months later, it was 2 years ago now, Microsoft acquired Citus data. So that's why, and that's the main reason why we today have the Postgres PaaS option, which is called Hyperscale Citus, because of this acquisition of Citus data. And that's definitely a game changer. As you see, there is over 6 million queries each day. On now, it's about 2 petabyte of data. And most of the queries, as you see, the response time, it's really impressive on this size of the data. If you would like to know more, there's a great blog post written by Claire Giordano, which describing in details this story about how many diagnostic metrics we do gather, how it works. There's also some videos or recordings on YouTube from PGConf where Minwei is presenting how he did the testing, why he decided to go with Citus instead of SQL Server, what was the motivation, and so on. So if you would be interested, that's the link for this blog post where you will find all the links. Okay, let's go to the Hyperscale Citus. So, as I said, it's an extension. We've got thousands of extensions for Postgres. That is one of it. We've got really simple extensions which do have 2 SQL function that is doing some specific calculation, but we also do have this one, which is totally changing the planner of Postgres, because Postgres do also allow that to totally change the planner and changing that into something else, into the cluster of Postgres actually, instead of single Postgres. And what's really important, it's not a fork, it's an extension, because if you fork a software and then you need to somehow merge with the recent changes, which could be really problematic and which could really take a lot of time and effort. Of course, extension, also you need to adjust to those changes, but let's say that the amount of changes isn't that big. And you do not lose anything from Postgres. So you don't lose, for instance, JSONP data type because you just added the Citus extension. JSONP will be the same. You will still be able to keep your JSON data inside and use the same indexes, use the same queries operators as you did before, except that you can use also, for instance, 20 nodes of Postgres instead of 1. And because it's open source, it's still open source. Microsoft acquired Citus data, but it hasn't changed anything. It's still an open source extension. So if you can download Citus totally for free from GitHub repository, for instance, and you can use it on-prem. In the cloud, that is one of the options of Azure database for Postgres. Currently, we do have 4 options because I believe 1 month or 2 months ago, we've got flexible server, which is Postgres on new architecture available on Azure, but Citus is still there as an option for Azure database for Postgres. So the main option always where you had single server, which is just the classic Postgres as you do have and you use it on-prem. And if you've got a bigger set of data, if you expect like your database would be a good fit for distributed database, you can decide to go to Hyperscale Citus, so to distributed shared Postgres. Okay, a bit about the architecture of it. So a Citus cluster, like in the classic picture, has got always one coordinator node. On Azure, you cannot have, at least now, more than one coordinator. So let's say you've got one coordinator and at least 2 data nodes, up to 100, depending, of course, of your cluster size. And you or your application is always like connecting to the coordinator node. It cannot connect to the data nodes on Azure. And this coordinator is just a classic normal instance of Postgres. Each data node is also like normal instance of Postgres. So instead of one instance, you've got, for instance, 9, 10, 20 instances of Postgres. Also, you don't need to change anything from the application level. You can use the same driver as you used for Postgres. You don't have to anyway to tell your application that for now on you will be using a 10 Postgres cluster. No, just you are connecting to the coordinator as you did before, and application things is just Postgres, just normal instance of the Postgres. So that kind of eliminates the burden of the application changes, of knowing how the data are distributing among the nodes and so on, because those kind of data are kept on the coordinator node. And once you query your Citus cluster through the coordinator node, Citus will get all the metadata information for you. So Citus, if you ask, for instance, for a customer ID 5, Citus will check the metadata that it keep on his node, right? And he will know that, like, for instance, on data node 4, it's the data for this customers are, and will just redirect the query to the proper node. So you don't have to change your application in any way. And a bit about the nomenclature, like the shard, it's actually the Postgres table, so that's so simple it is. And when we're talking about sharding, you might think about that as about partitioning, for instance, because shard is just like keeping a part of your data, part of your table in a smaller table. Of course, it is still like the same table, but it's just divided in smaller pieces. And those sharded are distributed among the data nodes. And also you don't need to care like on which data node the particular shard is. Citus will also do that for you. So you will just tell Citus, please, please, I would like to have 32 shards, and I will have 4 nodes. So Citus will automatically divide those data and place those shards with the data on the nodes and keep the information of that where the particular data is in the coordinator node. Yeah, a bit about terminology. So coordinator, it's this main Postgres instance that do keep all the metadata and that application connects to. Worker data nodes, those are the actual storage for the data. So on the coordinator node, you should not, in most of the cases, have any data of your database. It's like there are some exceptions, I will tell you about that. But in general, you should keep all your data on the worker node, so data nodes. And sharding is the process of dividing data among these nodes. And shard, it's like part of the data containing some subset of the rows. That's really one cool feature of the Citus, of this distributed database. And that is one of the things that makes your query really fast. Because if you've got a reference at some kind of tables that are connected to each other in the relational database, that's kind of obvious, right? That's you've got relationship with, like within tables. So all the data that are connected from those two tables will be put on the same worker node. So once you do the query, you don't have to like jump from one worker node to another worker node to get some like parts of the data and combine them together and do the magic with the network round trips. This query will be executed on this node where your data are kept. So that's the collocation feature of the Citus cluster. And it does handle joins. So if you've got joins, right, or those can be executed on the same node. Rollups, that's about analytics and other cool features. That's an animation actually, but because it's PDF, that's not an animation, just a picture. So basically, if you are doing a select account and you are filtering out by designer name as here and company ID, coordinator node knows that those data are kept on worker node 1, so you don't have to send over the data through the network and you can just execute this query on one of the workers. Also, another nice feature, because we're gonna have Christmas in 1 month, right? So like a lot of our customers, like retail customers, logistic customers, all those companies that are doing transportation and and many others expect increased load on their databases, right? Because Christmas is coming. So if you've got Citus cluster on Azure, you can just say, okay, I do expect increased load, so I will add 2 additional nodes to my cluster, and the data movement is so further dividing the data and placing those pieces of the data on the further nodes will be done automatically. You don't have to like worry about the data distribution. Citus will use the native feature of Postgres, which is logical replication, will do that in the background. And once the data are already placed on the new nodes, the metadata on the coordinator will be changed. And for now on, Citus will be able to use the increased number of the worker nodes. So kind of neat feature, especially before Christmas time. And I don't know if you recall, there's been really funny movie on YouTube that was comparing MySQL to some scalable Nosql solution, and there's been two people talking to each other. One of the guy was talking that, okay, but MongoDB is scalable. It supports sharding, and another one was I will not quote the whole thing because they've been using some bad words. But okay, but you don't care about if your data will disappear or so on. So basically, if you do talk about shardings and sharding solutions and NoSQL, you probably need to deal with some kind of data loss. But that's not the case with Citus. Because Citus is using two-phase commit protocol, which means that if you do update, if you do insert, if you do delete, there is no chance that those operations will not be ACID compliant. They will be ACID compliant. Of course, there is cost with it. So two-phase commit protocol isn't super cheap, but you can be absolutely sure that your data are there. Once you committed the data, you will not lose the data. It's it's got distributed architecture, but you don't need to worry that your data will be lost. That is Nosql modern solution. It's modern solution, it's great solution, but it will for sure not lose your data. Okay, shortly about table types. We've got 3 types of the tables in the Citus cluster. And the first one are distributed tables. So those are the most fancy ones. So those are the tables that are sharded. Those are the tables that are partitioned to small pieces and put it on worker nodes all around the cluster. And distributed tables should be those really big tables, and you should really carefully choose your distribution key. So you should choose the distribution key by analyzing your workload, by choosing the key that is commonly used in your where clauses, so a Citus cluster can use efficiently. And actually, if you already decided to choose the distribution key, so that would be the column name, and choose the set of the table that will be distributed in your database, you just running one single function, which is select create distributed table. You're putting here your table name and the column name, so the distribution column name, and Citus is doing the rest. So it's partitioning the data, it's moving those data onto the worker nodes. Reference tables are different types of the tables. Those are pretty small. So if you think about reference tables, those are, for instance, dictionaries. If you've got a dictionary with country names, with currency names, that you really often join other tables to, then probably this table should be the reference tables. Those tables are replicated in whole to all the nodes, and also if you do any updates, inserts, any operation on it, needs the writes needs to be done on each worker node, right? Because on each worker node, you've got the full copy of the reference tables. So so each time you do the write, you need to do the write on each node. But then if you're doing the joins with distributed tables, then it's really quick because Citus doesn't need to do these round trips between the nodes and gathering the data from these reference tables. And local tables, those are if you forget to use one of the functions, so select create reference table or create distributed table, then your table will land on coordinator node. And it should not. You should plan which tables should be distributed, which tables should be reference tables, and you should avoid the situation that your normal tables are on the coordinator node. Of course, there are exceptions, you've got, for instance, a system that tracks the changes to the database. So it tracks that, for instance, today I deployed some script to the database that did alter this table, drop this table, right? And I'm keeping the track, so the day, the username, and what changes were done, or just hash of the hash from Git, of the commit. So those tables are probably fine if they are small. They are not joined against. They are not a part of the business logic of the application, but are the, doing some side stuff this version compliance, let's say. Okay, and how it looks in Azure. So in Azure, you've got the Citus cluster, which always has got coordinator node, of course, and at least 2 worker nodes. So that's the minimal setup on Azure. If you would ask about backups, HA, and those kind of stuff, of course, it's a PaaS service. So you do have an automatic slider when you just move, and after that, the totally new cluster is deployed in another AZ availability zone. that is connected with the main cluster with the Postgres synchronous replication. So you've got RPO 0, and in case anything will happen to your main cluster, there's also like automatic failover mechanism that will switch the application traffic from the main cluster to the secondary one. And that's fully automated, so you don't need to worry about that. Of course, if you move this slider and enable HA, then you need to pay twice that much because also like the second cluster, so it means 3 additional VMs in these setups are created. So yeah, it does increase the cost of the whole cluster. And as other PaaS services in Azure, there are like automatic backups, which are by default kept by 7 days. You can extend to 35 days. And yeah, you can choose between geo-redundant and locally redundant backup also, and you can go back in time, so restore your cluster to the point in time depending how you've got like your backup setup. So if you've got like a backup only from 7 days, then you can go back those 7 days. If you've got 35 days, you can go even 35 days back. So the classic deployment of that. I'm checking the time, so slowly maybe I will skip this one and I will show you the Citus copy performance. And copy, it's the command in Postgres that allows you to batch load the data. So as you probably know, because like that's the case in all the databases, that single insert is really slow, right? If you want like to insert 100,000 of rows and you're doing that with single inserts, that will be super slow on each engine that exists. So in Postgres, we've got this copy command that can optimize the loading process, and it's really much, much faster than inserts. And in Citus, it's even much faster than in normal Postgres. And because Citus is able like to parallelize this copy command. So it's much faster, as you see, depending also, of course, on the core, which means, yeah, the reason is, of course, the parallelization of it. About the select performance, of course, depending what kind of workload you had, which kind of select that was, if select contained the workloads, which is also like this, yes, it's like distribution key, then it's gonna be super fast, as you see here. Yeah, and if you would like to have more, we've got like a lot of resources. There is, of course, documentation about Azure database for Postgres. There's a blog. You've got a lot of interesting details about that. You've got the migration. I can tell you that Citus is mostly chosen for people that do migrate from Oracle Arc as an alternative for Arc. It's open source, right? There's no vendor lock-in, and you've got also like many enterprise features on Azure, so it's really a common migration target for Oracle Arc. Yeah, you've got Postgres Quick Start docs, this blog, and the Citus newsletter, which like you can find them. There are like a lot of articles about Citus itself and about Azure. Okay, thank you guys. If there are any questions, I'm happy to answer. If you would like to contact me like offline, there's at the beginning of the presentation, you've got my Twitter ID. I'm happy to like answer all your questions.
Excellent. Thank you very much for that. Very good. Enjoyed that. So I've got a very quick initial question here about the choice of going to Postgres PaaS service and Citus in Azure. So let's just assume I'm a SQL person. I won't confirm or deny that. And you know, I'm looking at what service to go to in Azure. Why would I decide to go to the Postgres Citus service over, let's say, Azure SQL DB?
if you choose between Postgres and Azure SQL DB, right? That's the question.
Yeah.
Okay, that's okay. That's not an easy one. I don't want like to say something wrong because you are a SQL Server person. I'm Postgres person, so I would always like go to Postgres. But I think that the classic case would be the Oracle migration because like before this job, I've been doing Postgres tuning, consulting, a lot of other stuff. And actually now I'm doing only like Oracle to Postgres jobs. So a lot of people do migrate from Oracle to Postgres, and I would say that's the main trigger now. So, the reason for migrating from Oracle to Postgres, it's because PL SQL and PL PG SQL are so similar, and the migration effort is much smaller than migrate to SQL Server. I even have POCs when we compared the migration effort to go from Oracle to Postgres and from Oracle to SQL Server, and it's migration to Postgres is at least like half less than migration to SQL Server, and also you don't have this vendor lock-in, right? Vendor is this time Microsoft, and in Postgres you don't have any vendor lock-in.
Cool. Okay. Before we move on to Michael's question, the other thing from what you've just said is you say that it's a good migration strategy for Oracle RAC. I mean, I've had some experience in the past of RAC, and one thing I do know about it is it's insanely expensive to use. So I'm presuming
Yes.
this is actually a lot cheaper, is it?
Oh, yeah, it is for sure. Like, I could not imagine like something that is more expensive than Oracle, to be honest, like any database at all. So everything probably is cheaper than that. But yeah, it's cheaper. Of course, if you go with like cluster with 100 of worker nodes and like each worker nodes would have like 64 cores, that's super expensive, of course, right? Because if you even would like calculate the cost of the VMs without anything, that would be super expensive. But yeah, like if you compare the size of the Oracle to this one, like with Citus, it's much less expensive than that. That's for sure.
Great stuff.
So on that note, on the Microsoft webpage, it says something about Azure Arc enabled Postgres Hyperscale. Is that something else? So do you compete with yourself? A different thing or same thing?
So Azure Arc is really cool. It's like, I could not include all those stuff in one single presentation, so I haven't talked about Azure Arc, but I think it's really cool because you can run your Citus like on-prem, and you can run Azure Arc on AWS or on Google Cloud, for instance, and still you will have the same features of the Azure Postgres PaaS, the automatic upgrades, you will have the backups, you will have like HA and so on. So that's really cool and new feature, and I'm really happy that for the preview, Postgres Citus and SQL Server, those are the only two database engines that were chosen for this preview. So that was obvious that SQL Server would be chosen, right? Because it's like Microsoft engine. But I'm really happy that Citus was also chosen for this preview.
Is JSONP the same as Mongo's Bison?
No, it's not. It's totally different implementation. And you can, maybe the usage is a bit like similar, but in Postgres, that was implemented by the Russians. The Russians are really cool guys. They are the main contributors to Postgres. They are authors of not only JSONP, but also many indexes. And basically, if you Google that, Bing that, of course, then you will see that there is a lot of benchmarks which are comparing the performance of MongoDB and Postgres using JSONP. And of course, depending on the test and depending on the workload, sometimes Postgres is much faster and sometimes MongoDB is faster. So it's basically would say like it's got the same aim. It's got, you can use it like for the same stuff, but the implementation of it is a bit different.
Okay, thank you.
Perfect. A query that's related to high availability is, if the coordinator goes down, does that initiate a failover to the replica cluster? Or how
Yes.
does that work?
Yeah, absolutely. Yes.
So is it a failover for if the coordinator goes down, does it fail over the entire cluster, or does only the coordinator fail over
Yeah,
to the
it needs to
idle
like
one?
fail over. Yeah, it needs to like fail over the whole cluster, because we don't have like the standby for the coordinator on the main cluster. So it's basically like monitoring, like checking, the health of the coordinator, like let's say 4 times. If the 4th time it's also like, false, so the coordinator's not responding, then the failover is happening, yes.
Perfect, thanks.
So can you change your distribution key once you've set it? And if so, is that partition data then automatically reshuffled?
Yeah, so you can, but yeah, it will cost you like the like you said, like the whole reshuffling thing. If you've got like 2 petabytes of data, that could be a bit problematic, I would say.
Thank you.
So, but if you then have the wrong distribution key, so to say, can your costs increase if your query spans all the nodes just because of your partitioning being wrong?
So you mean cost by like dollars, euro, or
Yes,
like
exactly. Do my queries increase in cost because they touch multiple nodes, or is it some kind of load cost based?
Oh, I spot here like Cosmos DB user, right? No, so your cost will not increase, because you are like, it doesn't depend what you are doing on the cluster. Like, you are paying just for the hardware. So if you like spin up like 2 worker nodes, you are paying for 2 worker nodes, and it doesn't matter if you use it like at all, or if you're using that like to 100%.
Perfect, thanks.
What isolation level does Postgres Citus use? I'm going to guess it's snapshot, but tell me if I'm wrong.
Yeah, so depending what he's doing, right? But it doesn't change like the normal Postgres behavior. So in Postgres, we've got like all 4 transaction isolation level, and yeah, sometimes like Citus is using snapshot depending what is doing.
Okay, cool.
When you increase the number of nodes in the cluster, will the coordinator also autoscale?
No, it's completely not dependent to each other, and it doesn't need to like autoscale. Like, it's like keeping only the metadata. So it's kind of just adding like 1 row to the, worker node list.
Okay, so it's no extra job to coordinate or transfer information between more nodes.
No, it's more like, okay, there's initial phase, of course, like to distribute further the data. So like those shards needs to be splitted further. And then like logical replication kicks in. So this logical replication is like transporting the data to the new nodes. And once it's like those data are on those new nodes, then like, just metadata are updated, and that's all. So there's not much work on the coordinator at the time.
You talked about the copy command being an efficient way to ingest data. Does it do anything really clever, like pre-scan the data that's ingesting and send it to the right node, or will it just simply send it all through the coordinator?
So coordinator does that. So coordinator always, like when it got like copy, insert, select, delete, whatever, coordinator also will split, like change this query and and send the right query to the right node. So it always does that.
Cool.
Perfect. And then we have the last question from Nightin. How Citus plays against AWS Aurora concerning performance, cost, high availability across regions?
Yeah, I would not rather say it's better or worse. I can say that in Aurora you've got the same storage for all the nodes, right? So you don't really scale the writes, right? You scale the reads only. So in Citus, you scale both reads and writes because you've got like independent worker nodes which can handle both reads and write. And in Aurora, you can have kind of like classic Postgres replication, which I did like many times when I've been like consultant. So you've got the master and you like just adding slave, slave, and slave. So you can, all right, you can just scale the reads, not writes. Like, yeah. So that would be the main difference. About the cost, I have no idea how much it costs on AWS.
Probably lots of money since it's AWS.
Probably yes.
Okay, well, fantastic. We've come to the end of the questions now. Really appreciated you joining us, Alicia. Hopefully we can get you on sometime soon.
Really, thank you for having me, and have a great evening.